So the next topic is classification of second order linear PDE. Classification of second order linear PDE into hyperbolic, parabolic and elliptic. That is nothing but solving the given second order linear PDE to canonical form. So first let us understand what is canonical form or normal form. Canonical form or normal form. Using the transformation, that is from x, this is xy, if I transform this into xi and eta plane, using the transformation xi is equal to xi of x comma y and eta is equal to eta of x comma y, and converting the complicated second order linear PDE into simpler form. The simpler form which we will get now, that form will be called as canonical form or normal form. So why we need this canonical form, that we should understand first. So using this transformation, the PDE, second order linear PDE, ux plus e uy plus fu is equal to g. Using this transformation, this second order linear PDE gets converted into canonical form or normal form, so that the equation, solving procedure of the equation will become much more easier. In order to solve the problem in an easier way, we will use this canonical form. Okay. This second order linear PDE can be categorized in two ways. That is second order linear PDE with constant coefficients. With constant coefficients. That means here in our general linear PDE we have A, B, C, D, E, F and G, right? This all A, B, C, D, E, F and G will be constants or constants. If the coefficient of uxx, uxy, uyy, ux, uy and u is constant, then we call that particular PDE as second order PDE with constant coefficients. So if any of these coefficients, that is it may be A, B, C, D, E, F or G, any of these is a function of x and y, then we call that PDE as second order linear PDE with variable coefficients. The next category is second order linear PDE with variable coefficients. Okay, that means if any of A, B, C, D, E, F and G are either a function of x or a function of y. For example, uxx plus uyy is equal to 0. Here uxx is having a coefficient A, uyy is having coefficient of C. Check the general equation correctly. The coefficient of uxx is A, uyy is C and uxy is B. Don't get confused. So here A is equal to 1, C is equal to 1. That is, A and C are constants. And there is no B, D, E, F and G. This B, D, E, F and G will be 0. So this is the example for second order PDE with constant coefficient. Next category is second order PDE with variable coefficient, right? So if uxx plus x into uy is equal to 0. Here A is equal to 1, B is 0, C is 0, D is 0, E is x, F is 0 and G is 0. Look at this example. In this example, as I said, any of A, B, C, D, E, F and G are either a function of x or a function of y. Here E, the coefficient of uy is a function of x. Okay, so this example is called as second order PDE with variable coefficient. Okay.